Hello everyone, it's me, Aster, back with a new math video. I know it's been a while, but yeah, basically in this math video we'll be doing some basic trigonometry problems, six problems, four of more conventional problems like the ones you'll find in your textbook. The ones I'll be solving from are specifically from R.D. Sharma, class 10th, and two more unconventional ones that you may or may not encounter in most of the exams or anything related to trigonometry. But they're good to know. So anyways, let's start with the problems. So the first problem is cosec theta times root of 1 minus cos square theta is equal to 1. So we need to prove LHS is equal to RHS, right? So the first thing we're going to do is we're going to write cosec theta as 1 by sine theta, because that's what is defined as, right? And root of 1 minus cos square theta is equal to 1. We know from the identity that sine square theta plus cos square theta is equal to 1. So, we can just change this up and get 1 minus cos square theta by, transposition is equal to sine square theta. Right. So in the next step, we're just going to change this up to 1 by sine theta times root of sine square theta. Theta is equal to 1. Now this is a square and this is a square root. So, obviously we're going to cancel the both out. And we're just going to get sine theta by sine theta is equal to 1. And, x by x of anything is just 1, right? So we're going to get 1 is equal to 1 here, right? Plain and simple, easy problem. Now let's make things a little bit more tricky with the next problem. Right. So the next problem is cos square theta plus 1 by 1 plus cos square theta is equal to 1. These problems are specifically from the chapter of trigonometric ratios. So, you're mostly going to be facing problems like this. Basically, LHS is equal to RHS proofs, right? So, we'll be using the identity of 1 plus cot square theta, which is basically that 1 plus cot square theta is equal to cosec square theta. This is one of the basic trigonometric identities. The proofs are pretty trivial. You can do them yourself, but mostly we just apply them, right? So you're gonna get cos square theta plus 1 by cosec square theta. This is equal to 1. And we know that sine theta is technically speaking 1 by cosec theta. We can just derive that from previously what we know. So what we're gonna get is cos square theta plus sine square theta is equal to 1. And from the previous identities, we got that this entire thing is equal to 1, right? So we're just going to get 1 is equal to 1. So again, we've proven that LHS is equal to RHS in this problem, and thus the problem has been solved. Now the next one is definitely more trickier and most certainly longer, but not to worry, it's still pretty easy comparatively. So it's basically going to be cosec theta minus sine theta times sec theta minus cos theta times cot theta, this time plus tan theta, is equal to 1. Again, LHS is equal to RHS, right? So we can write cosec theta as 1 by sine theta, sec theta is 1 by cos theta, and cot theta is 1 by tan theta, which is, what they defined as again. So 1 by sine theta minus sine theta times 1 by cos theta minus cos theta times 1 by tan theta plus tan theta this time is equal to 1. Yeah, all good. So, we're going to take all of these having a common numerator in each of the brackets. So, we're basically going to get 1 minus sine square theta by sine theta times 1 minus cos square theta by cos theta times 1 plus tan square theta by tan theta is equal to 1. And using the identity that 1 plus tan square theta is equal to sec square theta, which again, common trigonometric ratio identity, whatever you want to call it, we're basically going to get sec square theta. And here, again, from the previous problem, we're going to get sine square theta, and here, cos square theta. Right. So we can just substitute those in cos square theta by sine theta times sine square theta by cos theta times sec square theta by tan theta is equal to 1 again, right? So let's just drag this down a bit, right? So over here we can cancel out the cos square theta and get cos theta, and this goes out as 1. Again, this cancels out, we get 1, and we get sine theta here, right? So cos theta, sine theta. There's nothing much we can really do here, but this side, however, requires some further simplification. So, sec square theta, we can write that as 1 by cos square theta, and tan theta over here, or cot theta basically, we can write this as times cos theta by sine theta, because again, 1 by tan theta is cot theta, and cot theta is basically, you can again be written as cos theta by sine theta is equal to 1, right? So the cos here cancels out and you get cos theta, and this is 1, right? And the cos and cos here cancels out, leaving 1 and 1 here. And then sine theta here cancels out and cancels out here 1. So you're just going to get 1 into 1, which is 1 is equal to 1. So again, LHS has been proven to be equal to RHS in this scenario as well. Let's just clear up the board real quick. And next we're going to be doing our last conventional problem, and then we'll be jumping on to the unconventional problems actually. Right. So our last problem is cos square theta by sine theta minus cosec theta plus sine theta is equal to 0. Right, so your most common intention here would be to write minus cosec theta as cos square, is by sine theta, right? 1 by sine theta, So you're gonna get minus 1 by sine theta plus sine theta is equal to 0. And taking common denominator, you're gonna get sine square theta by sine theta plus sine theta, and that's how you're probably gonna start by going off with it. But it's not really the right process to solve this problem, and instead we should be looking over at the sine theta part over here. So we have to multiply sine theta numerator denominator to get sine square theta by sine theta. So it's basically going to be cos square theta plus sine square theta, from this part, sine square theta, by sine theta here, common denominator, sine theta, minus cosec theta, right? Just keep this in mind, is equal to 0, right? And cos square theta plus sine square theta is equal to 1, as we've seen from the, ratios. 1 by sine theta minus cosec theta, I'll be writing CSC or cosec theta, multiple times. Right, 1 by sine theta is the same as cosec theta, so you're gonna get cosec theta minus cosec theta is equal to 0, and x minus x is always 0. So you're gonna get 0 is equal to 0, LHS is equal to RHS has been proven. So that's the end of our conventional problems. These are basic textbook problems, and now I want to go into some more unconventional problems that you won't really find in your regular textbooks or exams, but special level exams. The one I'm going to be doing right now is from the Canadian Team Math Contest 2023 paper, team round. Okay, so consider a triangle ABC, right? I just take this ABC, and it has been given that AB is 10 units long, right? And sine 3A, basically the angle, right? So sine 3A plus 3 sine C, 3 sine C is equal to 4. Basically construct, and then you wanna construct an altitude from C onto AB, and you have to find, mark D here. You have to find the length of CD. Find CD, right? So first you're probably gonna wanna have to figure out the angles themselves, right? And let's set up some rules here, right? The maximum value sine of x can go to, or its domain, basically the maximum of its domain is 1 max, right? That's its domain. Basically sine of x is always going to keep oscillating in the range of -1 to 1, both of them included, for all 360 degrees, right? So now that we have this set up, we can say, if we take sine 3a as 1, say sine 3a is equal to 1, just assume it as that, and sine c as 1 as well, you're gonna get 1 plus 3 times 1, 1 plus 3 is equal to 4, right? So that satisfies our equation, right? What if sine 3a is less than 1? Well, that would mean sine c would have to be slightly greater than 1, which again is not possible according to this. So we can just take this and work with it, right? So equate these two over here like this. Now what you're gonna want to do here is take this, and using sine minus 1 on the other side, we're gonna get 3a is equal to sine minus 1 of 1, right? And that's basically going to be 3a is equal to 90 degrees, pi by 2 radians if you want to take that, but 90 degrees is easier. And a is equal to 30 degrees, basically 90 by 3, right? Now sine c, if you do the same process, you're going to get c is equal to sine minus 1 of sine, inverse of sine, basically, my bad, of 1, which is the same as 90 degrees. So now that we have that ACB, right, and we know that C is a right angle triangle, so we can just make a new diagram, basically, putting it like this, right? It's not the best diagram, but like this, 10, we have that. So you have a right angle triangle over here, right? And this you have as 30 degrees. Now you're supposed to find what this base is gonna be on the hypotenuse, right? And for that, what you could basically do, you have to figure out the rest of the heights actually. And for that, basically what you're gonna need to do is sine 30 degrees is equal to opposite by height, right? It's like for sine A as we're taking this. So the hypotenuse is 10. We're going to take this as 10. And the opposite BC is, we're just going to take it as BC because we don't know the value yet, right? Sine 30 is 1 by 2. You can get that from any basic sine chart. BC by 10, right? And so you're going to get BC is equal to 5, just multiply 10 to both sides, BC is equal to 10 by 2, 5, right? So 5 units. Let's mark that down here. Now using the Pythagorean theorem, we can figure out the length of AC as well. So it's going to be 10 square minus 5 square, or basically 100 minus 25, which is 75, root 75, my bad, which is the same as 5 root 3 units, right? And the area of triangle ABC, I'll just use this notation, ABC is going to be 5 times 5 root 3 base into height by 2, or 25 root 3, right? So now we want to figure out what, area is going to remain same regardless. So basically we have to figure out what the height is going to be, CD, when taking AB as the base. Now that we know, since area is always going to stay same regardless of the base and height we take, right? Triangle, conservation of area, something like that. You're basically going to get 25 root 3 by 2, my bad. 25 root 3 by 2 is equal to BH by 2, where the base we know is 10. 10 CD by 2. For ease, let's just cancel 2's out on both sides. And then we're going to cancel 5 on both sides as well. So we're going to get 5 root 3 is equal to 2 CD, right? And CD is equal to 5 root 3 by 2, which is your answer. So basically for this triangle, the height that you're going to get, CD, is equal to 5 root 3 by 2. And if you go over to the document and check the answer, yeah, that's the answer, 5 root 3 by 2. So this problem has been solved. Let's just erase it real quick. Now, coming on to our last problem, it's a bit of a homemade problem, not completely. The base of the problem itself I found online, it was created by Ztune, so, thanks to that guy. But then I altered it a bit just to include trigonometry into this, right? So you're basically gonna have to construct 4 circles in such an arrangement, all having equal radii, right? So, 4 circles like this. And what you're basically going to do is you're going to take this diameter and take this diameter, right? So, they lie on the same line, and then connect these together. And according to the question, this value is 10, right? This length, and these are the centers. I'm just going to mark them for sake. And all R is same. So, all circles have same radii. So, it's part of the problem. Have same radii, right? Now, say you take one such radius from this circle and another radius from this circle, so that they're collinear, basically, right? A straight line. So you're gonna and say this is the angle, right? Angle theta. You're supposed to find angle theta here. Right. So what you're gonna have to do for this is basically try to find r, the value of r itself, basically. And to do that, you're gonna have to construct a rhombus out of this. So you're gonna take this and connect this and take this and connect this, take this and connect this, right? So this rhombus, all of the sides, since this is r and this is r as well, side of rhombus is of the length 2r, right? So we have that set, and we're also gonna wanna construct the diagonals as well, and we can take the property, or let's keep in mind of the property of rhombuses, that the intersection point of the diagonals are perpendicular to each other. So this is going to be a 90-degree angle that will be useful later for the later part of the problem, basically finding theta itself. But right now we're focusing on finding r, right? So we have 2r over here, and since this is also 2r, because this is r and this is r, we can take this length as r itself, right? So r and 2r over here, we know this entire length is 10, and this length is r, and this length is r as well, right? So this length itself, this part is gonna be 10 minus 2r, and the length of this is gonna be 10 minus 2r by 2, which is basically 5 minus r, right? So now we're going to use a Pythagorean theorem, because again, as stated, right angle, right? So r, 5 minus r, 2r, right? So 4r squared is equal to r squared minus 5 minus r squared, right? How we're going to take this? We're going to get r squared minus r squared, and minus 25 plus 10r, right? Because it's negative, doesn't matter really that much. Plus 10r, right? So minus minus. Okay, so this cancels out, these two cancel out. You're basically left with 4r squared is equal to 10r minus 25. And you're basically gonna have to use the quadratic formula for this. There's no real other way to solve for this equation. But just let's just do that real quick, right? And take the quadratic equation minus b plus a root minus b squared minus 4ac by 2a. It's been a while since I've used the formula. Yeah. So minus 4, so we're gonna get plus 10 plus or minus of b squared, which is basically 100, into minus 4 AC, right? So A is 4, C is 25, right? So we're gonna get 100 minus 4, so minus 400. Wait, what? Alright, so I found the error actually. It's again the one thing that messes up most people when it comes to algebra. Science. Yeah. So basically I'm supposed to take this as plus because this is hypotenuse and these are both bases. So fixing that real quick, we're gonna get 4r squared is equal to r squared plus r squared plus 25 minus 10r, right? So we're gonna get 2r squared minus 25, actually better to write plus 10r minus 25 is equal to 0. Right, so now that we have the right equation, we're basically just going to use a quadratic formula here, right? Minus b plus or minus root of b squared minus 4ac by 2a, right? So minus b, we're going to get minus 10 uh, plus or minus root of b squared 100 minus 4ac. So it's going to be minus 8 times minus 25. So minus minus cancels out. It's going to be 8 into 25, 4 into 25, 100, 100 into 2, 200. So it's going to be plus 200 by 2a. So, that's going to become 4, right? So minus 10 plus a root minus, this is going to be root 300 by 4. So that's going to be minus 10 plus and minus 10 root 3 by 4. And since length can't be negative, we're going to take it as minus, we're just going to cancel out the 2's as well. Minus 5 plus 5 root 3 by 2. We're going to take minus 5 by 2 out. And we're going to get 1 minus root 3, right? So that's our radius. We found the radius. The radius has been found. Actually, the radius is 2r, right? So the radius itself, wait, no, the radius is minus 5 by 2 into 1 minus root 3. I'm sorry for that. Now, time to find theta, right? So to find theta, now that we know it's a right angle triangle, we can simply use the formula sine theta is equal to opposite by hypotenuse, right? So sine theta is equal to opposite by hypotenuse, right? And we know the opposite side is the length r, and r we just found it out is minus 5 by 2 into 1 minus root 3. And hypotenuse is 2r, so that's going to be minus 5 into 1 minus root 3, right? So instead of going through all that, we can just assume this value to be some alpha, right? Same thing as r, never mind, we'll just use r, right? And we know the opposite is the length r, and this is the length 2r, right? So hypotenuse is 2r, opposite is r, hypotenuse 2r, right? So opposite cancels out, you get 1 by 2, right? So now that you have 1 by 2, sine minus 1, sine inverse of sine theta on both sides, so sine inverse 1 by 2, you're going to get theta is equal to sine inverse of 1 by 2, which is going to be 30 degrees, I believe. So, we found the solution. Theta is equal to 30 degrees. Wasn't that hard, frankly speaking. You know what? I was dumb. I could have just done this the entire time, 2r by r, to find theta. So my apologies. So we're just gonna change the question and add r. You know, that's fine. Yeah, we'll just put it at that. Yeah. So thank you for watching the video, guys. It's been a while since I did such math video. I got a new drawing tablet, so it's much easier to write. Probably should practice writing better more though. Will improve in the future. And thanks for watching. If you have any suggestions for the channel and everything, feel free to hit me up. I'm trying to upload on a more regular basis now, but don't expect anything on February. I'm really busy on February with exams and everything, and the next video is going to be a history one. I promise that. So, stay tuned and thanks for watching.